Ever wondered who created the nothing our universe sprung from? Let's dive into the heart of this fascinating question. Our cosmic journey begins with the Big Bang Theory, the cornerstone of modern cosmology. This theory posits that the universe, as we know it, originated from a singularity, a point of infinite density and temperature. Imagine all the matter, energy, space, and even time crammed into a space so small it's practically a mathematical concept. Now, the Big Bang was not an explosion in the conventional sense. Instead, it was the rapid expansion, the stretching of space itself. Think of it as a balloon inflating, with the galaxies and stars akin to the spots on the balloon's surface moving further apart as the universe expands. But here's the crux of our conundrum. If the universe was birthed by the Big Bang, what was there before it? The answer, as per our current understanding, is seemingly simple, yet profoundly complex. Nothing. You see, the concept of nothing in cosmology is not the same as the everyday understanding of the term. It's not merely the absence of matter or energy, it's the absence of space and time itself. This nothing is a state where the very laws of physics, as we understand them, cease to exist. But this leads us to even more intriguing questions. How can something come from nothing? And who or what created this nothing? It's like staring into an abyss, a void that dares us to fathom its depths. Our understanding of the universe's origins is continually evolving, shaped by new discoveries and theories. Some scientists propose the concept of a multiverse, while others ponder about quantum fluctuations and vacuum energy. Yet the birth of nothing remains one of the greatest mysteries in cosmology, a tantalizing enigma that beckons scientists and thinkers alike. To understand nothing, we must delve into the world of quantum physics. Here, the fabric of reality takes on a whole new meaning. Within this realm, nothing is not truly empty. Instead, it is teeming with a chaotic dance of particles and antiparticles. This is what we call the quantum vacuum. Imagine a space devoid of matter. You may think of it as a perfect vacuum, the epitome of nothingness. Yet in the quantum world, this space is far from being empty. It is filled with fleeting particles and antiparticles constantly appearing and disappearing. These are not just theoretical constructs, but have real, measurable effects. This is where the Heisenberg uncertainty principle comes into play. It states that we cannot simultaneously know the exact position and momentum of a particle. In the context of the quantum vacuum, this principle allows for the brief existence of particle-antiparticle pairs. These pairs spontaneously pop into existence, borrow energy from the vacuum, and then annihilate each other to return that energy. This is what we refer to as quantum fluctuations. These fluctuations are not just a curious side effect of quantum mechanics. They play a crucial role in the early universe, potentially seeding the structures we see today like galaxies and galaxy clusters. In fact, these fluctuations may be the reason why our universe appears the way it does. But how can something come from nothing? Well, in quantum physics, nothing is not what we typically think it is. It's not a void or an emptiness. Instead, it's a seething, bubbling brew of virtual particles, a hotbed of activity. It's a strange and counterintuitive idea, but it is one that has stood the test of numerous experiments. So, in quantum physics, nothing is a hotbed of activity. But who or what created this nothing? That's a question we'll explore further in the next scene. The answer may surprise you, and it will certainly challenge your understanding of the universe and our place within it. The origin of nothing is a topic of heated debate among physicists and cosmologists. Let's dive into some of the theoretical perspectives that attempt to address this enigma. First up, the multiverse theory. Imagine if our universe was just one of an infinite number of universes, each with its own laws of physics. This is the essence of the multiverse theory, a concept that suggests our universe was born from the nothing of another universe. A tantalizing idea, isn't it? But remember, this is a theory that's as spectacular as it is unproven. As of now, there's no empirical evidence to back it up. Next, let's talk about a concept that's as old as time, the cyclic universe. This theory proposes that our universe is just one in a series of many, each born from the ashes of its predecessor in a never-ending cycle of birth and death. It's like a phoenix rising from its own ashes over and over again. The nothing from which our universe arose then is simply the remnants of a previous universe. But again, this is a hypothesis that, while beautiful, lacks solid empirical support. There are other theories too, equally fascinating and equally lacking in empirical evidence. There's the idea of a self-creating universe where nothing is an unstable state that inevitably leads to the creation of a universe. There's also the theory that posits nothing as an illusion, that our perception of nothing is simply a result of our limited understanding of the universe's true nature. Are you dizzy yet? Well, hold on, because we're just scratching the surface. The origin of nothing is a mystery that's as old as the universe itself, and just as perplexing. While these theories offer intriguing possibilities, none can definitively answer who or what created the nothing our universe emerged from. The question, who created the nothing our universe came from, remains one of the greatest mysteries in cosmology. We are at the crux of a conundrum that even our most advanced theoretical physics struggles to unravel. The origin of our universe and the nothing it emerged from is like a cryptic riddle that our current understanding of physics can't quite solve. You see, our understanding of the cosmos is primarily based on two pillars of physics: quantum mechanics, which describes the behavior of the infinitesimally tiny particles, and general relativity, Einstein's theory that explains the grand scales of stars, galaxies, and the universe itself. Both theories have been incredibly successful in their respective realms. Yet, when it comes to the birth of the universe, they seem to clash. Quantum mechanics tells us that nothing is never truly nothing. It's a seething, bubbling cauldron of virtual particles popping in and out of existence. In this quantum realm, uncertainty reigns supreme. On the other hand, general relativity describes a universe that started from a singularity, an infinitely dense point of nothing. But how can nothing be both infinitely dense and a quantum vacuum at the same time? This is where the need for a theory of quantum gravity comes in. This elusive theory is the holy grail of modern physics, the key that could unlock the mystery of the universe's origin. It aims to reconcile the quantum and the cosmic, to harmonize the unpredictable quantum realm with the orderly universe of general relativity. Yet, despite decades of effort, a complete theory of quantum gravity remains just out of reach. String theory, loop quantum gravity, and other contenders have put forth fascinating ideas, but none have been able to fully bridge the gap. Each theory has its strengths and weaknesses, and none have been definitively proven. So we find ourselves standing at the edge of a vast unknown, staring into the abyss of the unresolved mystery of the universe's origin. The question, who created the nothing our universe came from, continues to baffle the brightest minds in cosmology. Until we have a complete theory of quantum gravity, the origin of nothing remains a tantalizing puzzle. Despite the mystery, physicists and cosmologists continue their quest to understand the origin of the universe. Unraveling this cosmic riddle is no small task. It's akin to piecing together a puzzle in the dark, where all the pieces are invisible and the image they form is unknown. Yet, undeterred, they march on, armed with their theories, experiments, and insatiable curiosity. In this relentless pursuit, the field of quantum gravity has emerged as a promising frontier. Here, scientists are attempting to reconcile the laws of quantum mechanics with those of gravity, in the hope that they might stumble upon the elusive nothing. It's a tantalizing proposition that could potentially redefine our understanding of time, space, and everything in between. Parallelly, cosmologists are delving deeper into the cosmic microwave background, the afterglow of the Big Bang, hoping to decipher its cryptic signals. Each new discovery, each faint whisper from the cosmos brings us closer to comprehending the genesis of our universe. Yet, as we edge closer to the truth, we must brace ourselves for the possibility that the answer may be more complex, more abstract than we can currently comprehend. It's a humbling reminder of our place in the cosmos, of the grandeur of the questions we dare to ask. While we may not yet know who created the nothing our universe came from, the journey of discovery promises to be as exciting as the destination itself.